right, so let's take a look at this one, which is Civ, and it's what I showed you in lecture last time, but now I got the hands-on part working. So this is the URL where you can get the new version of Civ that runs on modern emulators. Very nice. Civ.abk is right there. We don't need the source code. So I just download this thing and put it someplace, like say, I'll go to my home folder and 128 where I was doing the previous demo and just put it right there. All right. So now that I've found it, I'll open a Finder window showing me the Civ here. All right. And so now, the first thing I want to do is put it on the Android phone. So let's just find my phone. All right. And that's still got the Progressive app from before, but I don't care about that right now. All right. So, and let's not save any passwords. All right. So I just take Civ, drag and drop it on my phone. And there it says installing. Uh-oh. And I hope I didn't cancel it. I'll just do it again. Okay. I think it's on there. Let's take a look. Here it is, Civ. Okay, and I'll just click and drag and put it on my desktop. All right. So now I have this, and it's a password manager. So, all right. So I'm going to put in passwords. All right. Let me just bring my phone over here. All right. And so launch it. And the first thing it's going to do is, ask me to enter a password. That tells me it's already been on this phone before, probably from demonstrating it last time. So let me just get rid of it, thoroughly uninstall it and reinstall it to get back to the starting condition. So that's my settings, and then apps, and then Civ, and uninstall. All right. And now let's get back to home and just install it again. All right, and launch it again. There it is, and I like to put it on my desktop. All right. There, now it asks me to define the password the first time you launch it. So that's capital P and then the rest of password, and then 1, 2, 3, 4, 5, 6, 7, 8, because they have this password complexity rule. So 1, 2, 3, 4, 5, 6, 7, 8. All right, and I submit that. Okay, now I can put in a PIN, which is going to be 5678, 5678, and submit. All right, and now I have to log in with the password I defined, PASSWORD 1, 2, 3, 4, 5, 6, 7, 8. All right, now I'm into this. Now I can add a test password in here, like CCSF, and my username is, say, test user. And my email is testuser@ccsf.edu. Just any kind of junk will do. And some kind of password. Just so we have some data to steal. I'm going to save it. Now there's an entry here for CCSF. I don't care about the Google Password Manager, which would be a much better place to put it. I want to study the weakness of this password manager. So now I put in some data so we can practice stealing that data. All right, so now let's take a look at the permissions of this app. And this is very much what you'll see in reports of vulnerabilities on Android apps. Like there's a report I have seen in the news where they tested the VPN apps on phones and found them to be very badly written. And one of the main things they did was just look at the manifest to see what permissions they're using and how they're handling things. And we can see a lot of the same flaws here. So if you just go into Android Studio, you can just drag and drop the app into here. And then it will show you, in the top part, it'll show you the general structure of the app. And the Android manifest is just right here. So you can just click that to view it, and you can, it appears in the middle screen, and you can just read it right here. So this is a really handy way to do it. And so there's a few things to notice here. I go to the instructions. The first thing is look at the permissions. You'll see a lot of permissions that it defines. So let's take a look at the permissions here. I wonder if I can make the font bigger. Shift Control plus? No, not obviously. Anyway, so here you see uses permission, post notification, internet, read keys, and so on. Write keys. Yes, here's a few permissions being defined. Here it defines So it has some general permissions like access to the internet, which is an Android permission, and then it defines its own permission called read keys and write keys, which would apply only to this app. And it defines the protection level of them, and there's various other permissions defined, all right? Now, those are the permissions, and then we can look at the activities, and you'll see there's the activities are the visible screens. This is the main login activity, and it's exported, which means it can be launched directly from outside the app. And here's the file select activity, which is also exported. And here's the password list, which is exported, and so on. So a lot of things are directly available from outside, which probably shouldn't be. Like the only thing that should be available from the outside is the login activity, and everything else should only be accessible after you log in. But that's not the way this app is set up. All right, and so now we can exploit the published activity. Like if we want to see the PW list, you can just use the am start command in ADB to issue it, and all you have to give is the full path to the thing, which is this, com.with.secure.activity.pw list. So what we're going to do is first close the app, so it's no longer running and logged in, because that wouldn't be an interesting test. So I go here and close it. And now, just to demonstrate, if I open the app again, it's going to realize I'm not logged in. So it's going to ask me to log in before it shows me anything, which is, of course, what it should do. So let me just throw this away again to make sure the app is not currently running or logged in. And now I'll just launch it from a terminal. And I guess I'll clear, and that's pretty good. Okay, so now I'm just going to put in that command, which is the A to the start. All right, ADB shell gets me on the phone, activity manager starts an activity, and this just gives me the path of the activity to launch. So when I do that, it opens up the list of passwords on the phone without making me log in first, which is wrong, and that's because they exported something that shouldn't have been exported. So that's one of the security flaws. All right, then we can find the content providers, DB and file backup provider here. So here's activities, and those are all the visible. Here's providers. So here's the DB content provider, and here's something called read keys and write keys. Those are, here's the end. Here's the DB content provider. It's exported. And then it has some things you can do with permission. And here's file backup, and that's also exported. So a bunch of things are exported that shouldn't be here. All right. And then we can use JADX. This is how you exploit content providers. You need to run JADX, and you can do it after you've installed it, which is a JADX GUI in the command line. We've used this tool before. It's very handy, nice graphical tool. You can open the app, which is in my home folder, 128, and it should just be here, civ.apk. There. So here it is taking it apart. And in here, I can search with the search tool. And I just search for, I think, content : // Yep, content : // This is how you find things that refer to the content providers. There are content : // and there are 3 of them giving me the URIs here. And I don't care about the first part, I just care about the second part. These are the full URIs to content providers. And these things, of course, are the passwords, the keys, and the backups, and all those should only be available after you've logged in. But as we're going to see, some of them are available before you log in. So here it's ADB shell. It's a content query, and all you have to give is the URI to the content you're trying to get to. So that's the command that will attempt to access these things. Let's see if I'll just open a new shell here. Actually, I'll just use the same one because I'm done with this JADX GUI now. So I'll just give it Control-C and clear. And then, okay, so there's the command that's going to try to open the passwords content provider. And as you can see, it worked. It gave me a row of data. There's only one line of data, but that's the password I put in. Services, CCSF, username is test user, and email is testuser@ccsf.edu. The password is an encrypted blob. This didn't decrypt it, so there's that. But still, it showed me a bunch of information that really shouldn't have shown me without letting me log in, forcing me to log in first. And then we can try viewing keys, which again just uses the full URI we found before. When I load the keys, now it's going to tell me something we really should have seen more often, error while accessing it, security exception, permission denial. Now that's what you should get. We should be getting that for all this. It should be saying, you can't do this until you log in first. So without logging in, I'm not allowed in. But if you look at the actual permissions, it's Android path equals /keys. And if you read the documentation about Android path, it will tell you permission can be granted only to the particular data identified by this path. And the same thing is true of Adobe web browsers. The security model of Adobe web browsers, when you define security rules, they usually apply only to the exact path you put in. So you can do something like just misspell the verb, like G-E-T-T, and it won't apply to that. It only applies to get. It's easy to make this mistake. Yeah, that's right. And so the problem is with the slash at the end, if I just do exactly the same request and I add a slash at the end, it will no longer match the matching pattern for the permission, and now I'll get the data. So now I get the login password 1234, and the PIN, which of course gives me everything. So yeah, that's why they call this thing Civ. It is a demonstration app with pretty much everything possible wrong about it. And this is the kind of stuff a lot of people do. It's looking at the actual structure of the app and the manifest file and various activities and providers. That's why this is a pretty important project. It's pretty simple, but it does show you how you test for apps. And here's how you test for SQL injection. This is where you do a content query going to one of the databases, and you inject this projection thing is part of the query, like the where table equals kind of thing. And you add a single quote to the projection. Now here I have to first get a shell on the phone. All right, and then I can execute this. Otherwise, the bash or G shell command processor will not understand it. So you have to first make a shell get in the Android environment, and then you can execute this command. And now you'll get a SQLite error while compiling, and it'll tell you SQLite exception unrecognized token apostrophe. And that's the point. This is the syntax error caused by injecting an apostrophe, which is indication of SQL of command injection vulnerability. I was able to inject an apostrophe, and it misunderstood that as ending a string and expected the next word after the apostrophe to be a command. So now I have the ability to execute commands on the machine, and so I can now do this. I can inject a carefully written command. And what this is going to do, the projection is going to be star from SQLite master, where type equals table, and then semicolon dash dash to be a comment start. So the select is already there. The developer put the select in there. The developer wrote something like select data from passwords where something equals, and I'm putting it in there. So I'm just adding to the command. Yep, that's it. And so now I get all the data. I get row 0, row 1, row 2, and this shows the structures. So it shows me the tables that are there. The type is table, and this one is create table. This one has the table passwords, and this one is the table key password. Let me read it here where I said, hey, the point, there are 3 tables, including passwords and key. Yep, table key, there it is. This one here is create table key. And this one is create table password. So that's how they did it. This created table Android metadata. And this one has, here it is, create table passwords. So it's a little bit funny syntax, but the point is now I know there's a table called passwords and a table called key. And that's what you do to do SQL injection. You find the names of the tables and the name of the rows, then you dump out the contents. And so here's the command that will dump out the passwords. This is going to give me everything from the passwords table. And I get the same thing I saw before. I get the username, the email address. The password is still an encrypted blob. I haven't found a way to decrypt that with this simple command, which is, of course, for that you have to log into the app. But still, it shows the vulnerability. And that's the point of this one. These are various things you shouldn't be able to do in an example app where you get to see how it works. And when I read a lot of vulnerability reports, they've clearly gone through this process. And as we'll see, there are automated security scanners that will tell you about these things too, which we'll do in the future. So that's what I wanted to show you. Let me stop the recording.